Hey students, this is lesson 1-8. Our objectives here are to find the perimeter or circumference of basic shapes and to find the area of basic shapes. So go ahead and do a quick review here and I'll check back with you. All right, so here's our key concepts to find perimeter, circumference, and area. Some formulas you're going to use. And I'll just fill in the letters from the formula here. For a square, since both sides are the same, we're going to label them both S. For a triangle, we have a base, and we have a height, and we have the other two sides can be called A, B, and C. And for a rectangle, we have a base and a height. Doesn't really matter which one you consider the base and which one you consider the height. For a circle, we have a radius, a diameter, and a circumference. All right, so we're going to use those formulas. Finding the perimeter of a rectangle, that formula was 2 times the base plus 2 times the height. So we're just going to substitute 12 for our base, and like I said, it wouldn't matter if you use 5 for your base. And that equals 24 plus 10. Will you try that? What is the circumference of a circle in terms of pi? What is the circumference of each circle to the nearest 10th? So in terms of pi, our circumference is equal to, if we use the radius, we're going to use this formula, 2 times the radius times pi, or 2 times pi times the radius, however you want to look at that. And we're going to substitute for our radius 5 inches. So we get this, which is 10 times pi, and we're just going to leave it like that in terms of pi. Now, when we want to do it to the nearest 10th, that's that number, that's going to be 10 times 3.14159, whatever. But multiplied by 10 just moves the decimal over one place. So we're going to say it equals 31.4 to the nearest 10th. All right, you try that. All right, finding the perimeter in the coordinate plane. We are going to use a couple things here to help us do this. Remember, to find the distance between any 2 points in the coordinate plane, we can use the distance formula. So to find the perimeter of this triangle, we're going to go, we're going to have to add up 3 sides. So our perimeter is going to equal LM plus MN plus NL. And I'll do my little work down here. So LM, now if it's in a straight line, you really don't have to use the whole distance formula. You can just subtract the coordinates. So to find LM, since it's a vertical line, I'm just going to subtract the y coordinates. So let me write down the coordinates of each of these. This is -4, 3. And this is, N is 2, -5. And M is -4, -5. So the distance LM is just the absolute value of the difference between the y coordinates, so -5 minus 3, which is -5 minus 3 is -8. The absolute value of that is 8. So that's LM. Substitute that there. And ML, let's do MN. That's another easy one here first. MN is equal to, since it's in a straight line, again, we can just subtract the x coordinates to find that. -4 minus 2, get the absolute value of that. That's absolute value of -6 is 6. So MN is, MN is 6. I wrote this one wrong. This one should say MN there. And that's 6. And then L. And L, that's the one we're going to have to use the distance formula for. So to find an L, I'm going to do the square root of, so remember we've got to subtract the x coordinates, square them, subtract the y coordinates, and square them, then take the square root of that. So subtracting the x coordinates, that would be, I'll underline them here in red, that would be the -4 and the 2. And then subtracting the y coordinates, that would be the 3 and the -5. And then we want to do the square root of that. And that's equal to 6 squared plus 8 squared, which is equal to 100. Square root of 100 is 10. So there's my 10, and now I'm going to add them all up, and I get perimeter equals 24. All right, you try that. All right, problem 4, you design your rectangular flag for your city's museum. The flag will be 15 feet wide and 2 yards high. How many square yards of material do you need? Okay, so we want to know how many square yards we need. So let's just draw a quick diagram. And notice we're given this in feet and this in yards. So it's 2 yards high. And we're given 15 feet, but I think I'm going to convert that one. And we know there's 3 feet equals 1 yard. So I need to divide that by 3, and that gives me 5 yards. All right, and then to solve it, I just need to do the area of the flag is base times height, and that's equal to 5 times 2, which is 10. And I'm going to label it square yards. All right. Problem 5, we want to find the area in terms of pi of a circle. Area of a circle is radius squared times pi, or pi r squared. And in this case, since our diameter is 10, our radius is half of that, which is 5. And we want it in terms of pi, so I have pi times 5 squared. And 5 squared is 25. And in terms of pi, that would be 25 pi. All right. You try that. Okay, one last thing we're going to learn about is the area addition postulate. The area of a region is the sum of the areas of its non-overlapping parts. So we can split up something in a couple different ways, and you can pick any way you want, but I like a line right there. And since this is a square, I can use that information. I know that this side with this mark and this side with this mark are the same. So the height is 2 of those. So if I take this 16 divided by 2, I get this length here, and that length there. All right. So now I can just add up the 2 parts here. Area equals base times height. Or for a square, it's area equals the side squared. So 8 squared is this area. Base times height here. 20 minus 8 is this base, so that's 12. So I need to do 12 times 16 here, which is, I think that would be 192. Then I'm just going to add the 64 plus 192 to get my total, which is 256. And that would be in square meters, since I'm finding area. All right, you try that. All right, I like to split these up into squares. Squares are easy to find the area. Go ahead and do the lesson check, and I'll see you tomorrow.